final exam cheat sheet, picking up with problem number 6 right here on our final exam. The previous 5 problems all came from first semester, so that's pretty deep review. Chapter 7 moving forward is officially now in our second semester set of problems. These first 2 problems will both come from Chapter 7. One thing you'll see here moving forward is that the first 5 problems, we got one representative from each of the first 5 chapters, pretty thin right there. What we're going to see moving forward is going to get a little bit more depth to these problems in each chapter moving forward. Chapter 7 dealt with polygons and more specifically quadrilaterals as we move forward. The next problem we'll see that explored. But this was our first geometry unit of the year, so you're going to see a lot more shape diagrams like what we see right here on the screen. And in this problem, in Chapter 7, we are dealing with angles in polygons in general. And one of the things that we explored in section 1 of Chapter 7 is how in any given polygon, the amount of angle measurements on each of the internal angles has to follow a very specific formula. One thing you're going to see here on problem number 6 is you're simply going to be asked to solve for the variable x. And given this diagram, there's enough information to do that. It's going to be based on how many sides or how many internal angles this polygon has. So there's really going to be 2 phases to this problem. Phase number 1, I need to figure out how many total angles or total degrees have to exist on the inside of this, what apparently is a 6-sided hexagon. It's not a pretty hexagon, but it's a hexagon nonetheless. And so these kinds of shapes have a very specific amount of degrees that have to exist on the internal angles. If I can figure out what that amount is, then I can add all these 6 angles together and set them equal to that amount, thus creating an equation that I can solve for the variable, the unknown x, which happens to be in 2 places, but it's just a collection of like terms at that point. All right, so phase 1, figure out how many degrees have to exist in this shape. Your figure on your final exam will likely have a different number of sides. This is the formula we're going to use to figure out the amount. This was the first major formula, I say major, but the first formula that we dealt with in Chapter 7. N minus 2 times 180 degrees. This formula right here determines how many internal degrees have to exist in any given polygon, where n represents the number of sides of that figure. So in this case, you can either count the number of sides or the number of angles. Both will yield the same result. But in this case, there are 6 sides. So if I plug in 6 for n, 6 minus 2 is 4. 4 times 180 degrees tells me that the internal angle sum here should equal 720 degrees. Phase 1 complete. But this is an important thing. This problem is actually taken directly from the Chapter 7 test, and where a lot of students got marked down on this problem is that they just didn't show where this value came from. They got the correct value, the correct sum total for the angle measurements for the internal angles. They just didn't establish where it came from. And so showing this work will be necessary. At this point, now it's just adding up the angles on the inside. And this leads me to the second mistake that happened for the Chapter 7 test for a lot of students. They had an easy enough time collecting the like terms and just adding up the angles that they were given. The one that was left out quite frequently was this guy. This is an angle measurement. It's just that it's not shown in blue. This right angle box does mean that this has a 90-degree measurement. So I'll go ahead and start there with this one. Just be aware that that can pop up on your final exam again. But that 90 degrees plus, and I'll just work my way around the edge, pick a direction and just go that way. X was next, 120, 156, 145. And then we get this algebraic phrase here. I'm still adding it with everything else, so it's just x plus 9. Well, all of these angles added together give me that 720 I established in phase 1. At this point, I have a long sentence polynomial. Now it's just a collection of like terms, solve for the variable. So don't be afraid to use a calculator. What I'm simply going to do with this first part of this next work is I'm just going to combine all my numbers together. There are quite a few, so be careful with that. And it can help. You don't have to do this, but it can help to kind of cross them out as you add them together, just to keep track of them, particularly since there are quite a few numbers to add here. But let's just work our way down the line. 90 plus 120 plus 156 plus 145 plus 9. 520. We've officially collected all the numbers together, so when I condense that down, all my numbers here on the left will come down to 520. And again, if you had crossed these out as you went, you would see that you'd have 2x's left over. When I add x plus x, I get 2x. And on the right-hand side, it's still equal to 720 degrees. At this point, this is a very familiar type of algebra problem. I'm just using inverse operations to get x by itself. So the first thing we're going to move is this positive 520 by subtraction. And I'll get 2x left alone on the left. And after I subtract 520 from 720, I have 200 left over. Simple division at this point tells me that x equals 100. So again, the two phases, just to summarize here. Phase one, first establish how many degrees have to exist in the given shape. Again, this number will be different depending on the number of sides of the given figure. And then phase two, add up all those angles, however many they might be, set them equal to whatever number you got from phase one. And at that point, it's just collection of like terms, move stuff away from the variable, solve for your variable. There's problem number 6 on your final exam. Let's move on. Problem number 7 is also going to come from chapter 7. Again, our first geometry unit of the year. This one is going to come from chapter 7, section 2. So in 7.1, it was based around the general polygon. It depended on the number of sides of the figure. Number 6 will reflect that. You'll see a many-sided figure, one that's typically not one that's going to be familiar to us. In problem number 7 here, now we're going to be in chapter 7, in section 2, we moved into quadrilaterals specifically. Quadrilaterals being the family of 4-sided figures, but we got a little bit more specific even still. In this case, we dealt with something called parallelograms. Parallelograms are a set of 4-sided figures, and they have baggage with that name. A parallelogram is a 4-sided figure where opposite sides are parallel to one another. And so you get very specific sets of shapes. One can think of it as like a frame, right? If you were to kind of slide the frames one direction or the other, it's going to force the other guys to follow each other and remain parallel. But anyway, we end up with this kind of shape. And you'll be given a figure like this. Now, this problem is actually taken directly from our Chapter 7, Section 2 notes, but you're going to be given some algebraic phrases in this diagram, and you're going to be asked to solve for some given variables. So, for instance, in this diagram, we're told that this length up here on the top is 3y minus 1 units, whereas on the bottom, it's 20 units long. And then we're also given some degree measurements here. We're told that this upper left corner is 54 degrees, and this lower right corner is 2x degrees. Just be aware of the difference of measurement here. Nothing's really going to change with how we set up equations and stuff, but be aware, like, for instance, 3y minus 1 and 20 are lengths. They have to do with the lengths of a given side, whereas the degree measurement that we see here for these internal pieces refer to an angle measurement. Simple difference in geometric objects, but nothing's really going to change from what we do moving forward. Okay, so in Chapter 7, Section 2, you'll find a list of properties of parallelograms, and that's really going to be the focus of this problem, where we're going to use the properties of parallelograms to create equations that we can relate pieces of this diagram to each other to solve for the variables. Because I can't just plug in numbers and guess. I need to set up an equation and solve what's happening. So there are going to be 2 different properties we're using in this formula to solve for each of the respective variables. Let's start with x. So if I want to start with solving for x, one of the properties in section 2 here in chapter 7 says that in a parallelogram specifically, and that's going to be the key operative here, the fact that we're dealing with a parallelogram. In a parallelogram, opposite angles that are opposite each other in that parallelogram have to be what are called congruent. And congruence means that they need to match each other. So from an equation standpoint, I can take that upper left 54 degrees and set it equal to that lower right 2x degrees. This is made true, again, by that property that says opposite angles in a parallelogram have to be congruent. This reflects that. At this point, I have a simple equation. Divide both sides by 2. X here is 27 degrees. Variable 1 solved for. Now for solving for y, we can't use the angles theorem here because these aren't angles, these are opposite sides. But thankfully in section 2, there's a very similar equation here that says that opposite sides in a parallelogram must also be congruent, meaning they have to have the same measurement. Meaning, from an equation standpoint, that 3y minus 1 on the top must equal or match the 20 units on the bottom. Again, the property that makes this possible is the one that says opposite sides in a parallelogram must be congruent. Again, at this point, now it's just a simple algebra problem. First thing I have to do here, this is going to end up being 2 steps, but I'll add 1 to both sides. I'll get 3y equals 21. At this point, now I just need to divide by the 3, and I'm going to get y equals 7 units. Done. Well, there's problem number 7 from our final exam. You just have to basically make sure you set your equations equal to each other properly. Opposite sides are congruent, opposite angles are congruent. Those are the 2 properties we used here in this example. Be prepared for the others. You can find a full list of the properties of parallelograms in Chapter 7, Section 2. But I'll go ahead and stop the recording right there.